Okay. In this section, we're going to try to connect trigonometry to a new formula for the area of a triangle. So if you guys recall, the area of a triangle is typically given as 1/2 base times height. Okay, in a right triangle, this is fairly evident because base times height, if you multiply those, you get a rectangle. You cut that rectangle in half, and you get the area of your triangle. With triangles that are not right triangles, it's still 1/2 base times height. Okay, so it's still 1/2 of base times height, where base, is all of this, height is right here. And you can go through some algebra to show that. So if we call this like little distance x and the whole thing is our base, well, then this is going to be the base minus x. And we're going to basically have two right triangles to find where we'd still do 1/2 base times height. So for this right triangle, we would do 1/2 of x times h. And then for this triangle, we would do 1/2 of b minus x times h. And if we go through this, which we can real quick, won't take too long, we get 1/2 xh plus 1/2 bh minus 1/2 xh. Right? I'm distributing this b minus x, or b minus x is being multiplied by h, so we get bh and we get minus xh. So we get all this stuff, and then these two cancel out with each other. So we just get 1/2 base times height again. Okay, so what I'm illustrating there is that easy to see in a right triangle why area is 1/2 base times height. It takes a few steps to show why it's true in any given triangle, but we can show that. So that is our area of a triangle. Now, what they're going to talk about in our textbook here is that there's a way to do this even if you don't know what the height is, as long as you know one of the angles. And the reason there is because if you know the angle, you can kind of figure out the height. Now, that's not entirely intuitive based off the equation they give you. So I'll write out the equation they give you real quick. They say that area equals 1/2 AB sine of C. Okay, where, let me draw out a triangle so that we know what we're talking about with these A, B, and C's in here. If we have some triangle with corners that we're going to label A, B, and C, then this little a and this little b, oh, it's a big C. Little a stands for the length that's across from A. Little b stands for the length that's across from B, and little c would be over here. Okay, so this is kind of how you'd typically label the sides and the corners of a triangle. So this is saying that you can get the area by doing 1/2 of this length times the sine of this angle C. Now, that is not intuitive to me when I just look at that. It's when you have like a right triangle and you're saying base times height, okay, that gives me a rectangle, so then I cut that in half to get the triangle. That makes sense. But when I see multiply A by B, when I say multiply that length by this length, well, I don't know about that. That kind of looks like if I could take that A side and kind of open it up, I would get a rectangle and I could work from there. But it's not an obvious picture to me. But we can show that it's true if we can just show that this is the same as that, right? So we can kind of ignore the 1/2. We can ignore the 1/2 here because that's in both of them, right? So if we say that 1/2, let me just write that out. If we say that 1/2 base times height needs to be telling us the same thing as 1/2 AB sine C, then what we really need to get to, well, the 1/2 is on both sides, so we can just get rid of it and divide by 1/2 on both sides, or multiply by 2, either way you want to say that. We can divide by B on both sides and get rid of the base length. Well, let me think about that. Do I want to get rid of that quite yet? Let's keep it for now. So base times height should be the same as AB sine C. Okay. Well, what is the sine of C? Okay, so sine is typically, sine, cosine, and tangent are typically done from right triangles. So the first thing we want to notice on this picture is that this is not a right triangle yet. I can make it into some right triangles if I drop a line down right here. Okay, so if I drop that line down right there, then we do have a right triangle. And we can talk about what sine of angle C really means. So sine is part of SO in SOHCAHTOA. It's talking about the opposite and the hypotenuse. So it is talking about the opposite would be, this guy right here, and the hypotenuse would be A. So the sine of C should be the opposite side over A. Okay, so we can maybe put that in over here, opposite over A. Okay, so if we have that, then what we're going to get is we're going to cancel out our A's. We're going to have the base times the opposite side. Well, the opposite side is what we would have otherwise called the height, right? That is the height of the triangle. So we just get the base times the height. So we get the same equation. Now, whether or not you're comfortable with that connection, um, it's fine if you just want to kind of memorize this equation. That's not usually the best way to proceed in math. It's best to kind of have an intuition for how this works. But you can kind of go through steps to draw out why this will give you the same thing that that does. Key point here is that if you don't know the height, you do know an angle. There is a method by which we can find the area of a triangle, and it's just this. Area is 1/2 AB sine of C. Okay, so let's look at example 4 here and try to use that equation, 1/2 AB sine C. Let's try to use that to solve an example. Okay, so they're giving us this triangle right here, where the area should be equal to 1/2 of AB. Well, what is A? A is the length across from angle A, this little a, right? Lowercase a. So that'd be 11.1. B is the length across from angle B, so 14.1. And C was given as 47 degrees. So we're going to say sine of 47 degrees. At this stage, we just take it to a calculator, right? Sine of 47 degrees is going to be some value that has been established previously. So we can, if we had a table of values, we could go through and find it. If not, we can just use a calculator, and they will use some calculus techniques to get it for us. So I see 0.73 as my answer. Okay, sine of 47 degrees is 0.73. So we're going to be taking that, multiply it by 1/2. So I'm going to call that 0.5 multiplied by 11.1 multiplied by 14.1 multiplied by that sine of 47 degrees. And our answer appears to be 57, I'm going to say approximately 57.2 units squared. I'm not sure what those units were, if they're meters or feet or whatever they were, but I'll just say unit squared because it's an area. Square units are areas. So 57.2, and that's how we get there. We do 1/2 AB sine C, where those little letters, little a, little b, stands for the distance across from angle A, the distance across from angle B, and sine of the capital C just means the sine of that angle, which you get through a calculator. Okay, and that is all it takes to find the area of a triangle when given an angle. Okay, we'll take a look at one more of those angle examples, area examples in the next video.